jumping into 1.3.2 for your practice assignment. And we're talking about equivalent expressions. So we want to show that P is equivalent to not P. So the double negation using a truth table. So I'm going to have P, I'm going to have not P, and I'm going to have not P. There we go. So P, only options for P are true or false. So then if it's not P, the true becomes false, the false becomes true. All right, and now we're going to not P. So we're going to do the opposite of this row, which is true and false, and those are equivalent statements. So that's how we can show that those are equivalent using a truth table. Next, use the truth table to determine if the following statements are equivalent. I am a homeowner. Sorry. If I am a homeowner, man, I'm struggling to speak today, you guys. If I'm a homeowner, then I pay property taxes. I am a homeowner and do not pay property taxes. So are those equivalent? So let's get some P's and Q's out here. We're going to say P is I am a homeowner. I don't know why it's so hard for me to say homeowner. Q is I pay property taxes. Right? So then this statement, if I am a homeowner, that's P implies I pay property taxes, so P implies Q. And then I am a homeowner, that's Q, and that's the conjunction, I do not pay property taxes is not Q. So we want to see, is the condition of P and Q the same as the conjunction of P and not Q? So here we go. We need to make a truth table. We've got P, we've got Q. We need a not Q. We also need a P implies Q. And we need a P and not Q. Those are my 5 rows here. All right. You only need 4 rows on this one. Like split this in half and another half because we're only talking about two statements. So 2 squared is 4. All right, so here we go. P can either be true, so the first 2 I'm going to write true, or it can be false, so the next 2 are false. Then to pair up all my variations of true and false, I'm alternating. This is true, this is false, this is true, this is false. All right, so not Q is going to be the opposite of this Q line. So if Q was true, not Q is false. If Q is false, not Q is true. Okay, then P implies Q. The rule for conditionals is if P, the premise, is true and the conclusion is false, that's the only time we get a false in our bracket. So if it goes true, then false, that's the only time we get false. So here we go. P and then Q. So I'm only looking at the first 2. That's true, true. All right, that's true. True, false, that's the only time we get a false. False, true is fine. False, false is also fine. So those are both true. All right, now we're going to do P, the first row, and not Q. Remember for and, the conjunction, we can only do it if both are true. Both have to be true for it to be an and. All right, so we've got P and not Q. So P is true, not Q is false, so this is false. Bam, we already showed that they are not equivalent because blue and blue are not equivalent, but we can keep going. All right, P and not Q are both true, so this one's true. Both false, that's false. False, true, that's false. So P implies Q is not equivalent to P and not Q, which makes sense, right? Like if it's true that I'm a home owner, then I pay taxes, but you're a homeowner and you don't pay taxes, that doesn't make any sense. Those are not equivalent statements. Okay. I'm gonna pull up De Morgan's laws right now. La, 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 la. Um, Here they are. All right. De Morgan's law says if you have the negation of a conjunction, P and Q, that is equivalent to not the conditional. P implies Q. So, oh wait. P and Q is given by, oh, sorry. I messed this up a little bit. This is given by, sorry, not P and Q. There we go. Is equivalent to not P or not Q. There we go. Wonderful. Then the negation of the disjunction is provided by not P or Q is equivalent to not P and not Q. All right. So in words, write the negation of the following statement. It is Friday and I receive a paycheck. Okay, so this is a conjunction because we're at, or we have and. So we're say P, it is Friday. Q, I receive a paycheck. Okay, so P, this is P and Q. Okay, so this is P and Q. We want the negation of P and Q. So we're going to use this sentence. So this is the negation of this statement is I, so we want, hold on, not this. So it is not Friday. Okay, so that's not P. Or I did not receive a paycheck. That is our negation of this sentence. So you're just doing this last part, not P or not Q. All right, next one. My computer is broken or the internet is not working. So my first statement is my computer is broken. My other statement is the internet is not working. Okay, so just split that apart and it's or, so this is a P or Q statement. So using De Morgan's laws, here I go. The negation of P or Q is equivalent to not P and not Q. So this is, I'm going to write not P and not Q. So this would be, not P would be my computer is not broken. And then, and the internet is working. Okay, and last one. Rainy weather is sufficient for watching Netflix. So this is a conditional. So that's, we're going to use another law here, another equivalent statement. So if it is sufficient, that means that this is the premise. So this is written as like, let's see, rainy weather is sufficient for watching Netflix. Or we can write this as rainy weather implies we're watching Netflix. So this is P, this is Q. Remember, sufficient is the premise. If it said watching Netflix is necessary for rainy weather, that would also be an equivalent statement. So necessary implies that that's the conclusion. Sufficient implies that that's the premise. So that's why this is the leader here. Okay, so we need the conditional and its equivalent statement. So we're moving away from De Morgan's laws. Try some other equivalent statements. So that is this conditional. I'm going to write it down over here. P and not Q is equivalent to not the conditional. That was from our example earlier today. So we want to show the negation of not this conditional. So we're going to use P and not Q. So here we go. P was rainy weather. So I don't know, the weather is rainy, I guess. The weather is rainy. And I'm not watching Netflix. That is the negation. There you go. That is the end of 1.3.